So we know that Revit is a great tool for generating the form of the overall building and then creating plan sections and elevations from that. One of the other things that Revit does really well is it can create really detailed model views. Now, we don't, of course, typically generate this level of detail for the whole building. It would create a file size that was much too large and it would just be unnecessary. But where it might be needed, we can create this level of detail. And one of the nice things about doing it in Revit is that, of course, once we've done it, then we can just create views and drag them onto sheets. If we were to do this in another program like 3D Studio Max or AutoCAD, then we'd have to worry about rendering and setting up views and exporting images and then importing rasterized images. So just to kind of skip all of those steps, we can just do our 3D detailing right inside our RVT file. The way that works is it involves maybe one extra step that you might not expect from another program, and that is that we have to add a reference plane. When I'm working away in Revit in a floor plan view, Revit just makes the assumption that all the extrusions, for example, my walls or my floors or my roofs would just be based on that particular level. But whenever I need to create something from an elevation or a section view, Revit needs some more information about where in that infinite horizontal plane to place the base profile for that extrusion. So to do that, I've just gone to the Architecture tab and I've used the Reference Plane tool. And it's just a simple two-click process. You just click and then you drag your line, and that would then be your reference plane. Now I've already got one created down at the bottom here, so I'll just delete that one. And note that when you create it, it also prompts you or allows you to click on the default name and customize that. So after I created that reference plane, I just clicked and named it Front Detail. And I'm going to need that reference plane when I start to do my extrusions from an elevation view. So I'm going to work initially on a steel stud wall. My intention is to build a bit of a spandrel panel here. And to begin the process, I want to go to my south elevation view. And what you see here is a 2D detail. So there's no three-dimensional geometry here. It's just a 2D detail. And I've pulled this in from the Revit Detail Component Library. So that's the first step. Use as much as you can from elements that have already been built. There is a really extensive list or selection of 2D details available in the Revit library. So wherever possible, we're going to use those. This one was retrieved by going to the Annotate tab, clicking on the Component tool, and then selecting Load Family. And in the library, this particular detail was located way down deep in the non-load bearing wall framing folder. So you can see the route there. I went from libraries all the way down to this folder, and that gave me access to a bunch of two-dimensional profiles that are relevant to steel studs. And this was the one that I selected, so M_interior metal runner channels. And then when you click open, it'll allow you to place it. And once it's placed, you can actually be a little bit more specific about the initial dimension. From the library, it was a 63mm profile, but once I had this selected, as you can see here, you can just click on your type selector and then just choose something that might be a little bit more appropriate for the size we're going to use, which is going to be 150mm. We're actually going to modify it just a little bit more to be a little bit more precise, but we'll just stick with 150 for now. So as I said, this is 2D data. This does not show up in a 3D view. And that being the case, it forms a sort of reference for us when we want to create our actual extruded 3D geometry. To do that, I'm going to use Model in Place components. So on the Architecture tab, I'm going to select the bottom part of the component button so that I can access Model in Place. And it'll ask me for a category, and I'll just choose Generic and click OK. And it'll give me a default name, which I'll accept. And now you can see I'm in sketch mode, green check, red X over here on the right, and then I have these extrusion and other modeling options. So when I click on extrusion, this is where we're going to see the need for that reference plane. Because I'm in an elevation view and it doesn't have a level to base this extrusion on, it needs to know where to actually place that sketch. So I'm going to click on name and look for the reference plane that I created earlier. There it is, front detail. And now when I click OK, I'm ready to start drawing, and I'll be right on the front face of the slab. And because I've got some 2D detail information there from the component library, I'm just going to rely on the Pick Lines tool and start clicking on what's already there to form the basis of the profile for the extrusion. It requires a little bit of cleanup, so I'm going to use my Trim Extend to Corner tool just to make sure that I avoid any gaps or overlaps. Now, if I was satisfied with the dimension of this profile, I would just do a mirror copy and leave it at that. But as I said, I want to be a little bit more precise and extend this out a little bit more. So what I'm going to do is I'm going to select all the elements on the left. I'm going to use the mirror draw axis tool, snap right to the midpoint, and draw up, and that will create a copy of those elements right on the edge of the profile. So that does look reasonably accurate, but I'm going to extend it out just a little bit. I'm going to grab these elements on the right, click on the Move tool, and enter 2.4 millimeters, just to get something that's a little bit closer to the actual 6-inch conversion. This will warn me that there's been some unjoined line work. That's fine. I'll just accept that and click Unjoin Elements. And to bring them back together, it wouldn't let me finish the sketch if there was a gap like this, so I'm just going to drag that over. Once I've got a completed sketch without any gaps or overlaps or extra lines, I can click on the green check. Before I do that, though, I just want to maybe specify that I want an extrusion end here 3,000 millimeters away, so it's going to run the full length of my concrete floor slab. And then I'll specify a material as well. And I just chose something that was close to a metal finish. It actually has a metal stud material, so I chose that one. I'll click on the green check, and I'm going to go to a 3D view, confirm that it extruded the right way. If it went the other way, if it kind of came towards your view, then you would just change the extrusion to be maybe negative 3,000 instead of 3,000. Notice that I'm still in sketch mode. It's anticipating that I might want to add some other modeling steps like blends or sweeps or voids. That's not the case here, so I'll just click on the green check one last time, and now I can see that I've got my completed lower track here for the steel stud wall. Back in the south elevation view, just be aware that I still have some lingering leftover 2D detail geometry that I want to get rid of, so I can avoid confusion and not end up copying that. So I'll click on that and just hit delete. I'm done with it. And I'm going to now just select my bottom track. And I'm going to use the mirror draw axis tool and just kind of randomly create the top track. And now I can go into creating the vertical steel stud. So I'll kind of repeat the same process. I'm going to go back to my level 1 floor plan view. And there you can see the extruded lower track. And I've placed here the 2D profile from the library for the vertical stud. So I just repeated the same process. I just went to the Annotate tab, clicked on the Component tool, Load Family, and that vertical profile was just a little lower down the list here. It's this one right here, M Interior Metal Studs section. It comes in, as you can see, at you'll probably see a smaller size, but regardless of what size it comes in at, we want to place it. And then we want to do a little bit of a modification here. I want to actually have it fit nice and snug right to the inside face here of the steel stud track, of course. So it's going to require a little bit of tweaking. Now, the way that it sits right now, you can see that it's actually, I'm not seeing both lines, as you can see there. So just be aware that you might want to just change your view range. So I'm going to type in VR for view range, and I want to have my cut plane right through the middle of that lower track. So that's going to require that I set my cut plane down to something really low, like 20 millimeters, and maybe even a little bit lower. And perhaps I'll switch this over to, there we go. So switching it over to wireframe accomplishes the same thing. As I said, want to make sure that when I move this steel stud into place, that it's sitting right on the inside face of the track walls. So this, of course, at the moment is still just the 2D profile. So I'm going to go into those same set of steps now to generate the actual 3D extruded geometry. So on the Architecture tab, once again, Component, Model in Place, Generic, click OK to accept the default name, and then we'll go back to Extrusion, and we'll use on the Draw panel here the pick lines, and we'll just kind of repeat the same process. So using the left side initially as a reference for the shape of this extruded vertical steel stud, I'm going to use the pick lines tool, and I'll clean it up with the trim extend to corner. And I'm going to kind of do the same thing where I just extend it a little bit on the right side. And I can start that process by just clicking on what I've already got using the mirror draw axis tool. I'll snap to the midpoint. You'll see that it now sits in exactly the same spot over on the right, but I'm going to use my move tool and just extend that out so that I get something that's a little bit more accurate for that 152.4. Now that the line work is done, I can just specify an extrusion end here, and I'm going to just kind of randomly assign something and then assume that I'm going to fix it later. So I'll enter 300. I can see the material here is still set to metal stud, and I'll click on the green check and do that a second time, and now I'll go to a 3D view and evaluate. Okay, so there I have now my top and bottom tracks. I've got my vertical steel stud, and I'm going to go to my south elevation view and just be a little bit more specific about exactly what height I'm using to extrude this to. To accomplish that, I'm going to rely on a 2D detail line. So I'll click on the Annotate tab and click on Detail Line. And I want to just maybe use pick lines here and enter 300 millimeters, let's say. And that's the height, of course, of the steel stud. And what I want to do now is maybe just bring up my bottom or my top steel stud track and just have it fit nice and snug. Okay, so that is my steel stud wall. Of course, at this point I might want to just create additional copies of my vertical steel stud, maybe spaced at 600 millimeters. But what I want to do now is get into how to create some of the more complex geometry, like for example the mullion. So I'm going to go back to my south elevation view, and Revit does have some mullion profiles in the detail library, but I'm actually going to go to the internet to track down something from a manufacturer. So I'm going to go to bimobject.com, and in the BIM Object search window I want to type in Conair 1620. And you'll see on the far left that we have the 1620, and if I just click on that, I can access the 4 downloads that are available for this particular type from Conair. Make sure you're logged in, and then you'll be able to just click on download, and I'm going to select this option over here on the left and download that file. One of the reasons why I'm choosing that particular file is because when I open it, you'll see that it's got a lot of really good 2D detail information, and it also has something specific to the spandrel panel. It actually shows a little bit of the back pan. So I'm just going to navigate to that spot and choose my Conair 1620. And we're going to repeat the process that we used for the components that came in for the library somewhat. There's a little bit of variation here because of course it's not in the same RVT file. So we can't just place the component directly from the detail panel on the Annotate tab. We're going to have to do an extra step. Now you can see that there's a bit of an upgrade going on here. This is upgrading from a 2012 version. I'll just pause while that takes place. Okay, so when the upgrading is done, you'll see this. And you see the 3D geometry, of course. We're not relying on this, though. Generally speaking, the downloaded mullion files that you'll see For curtain wall, they're not going to have as much detail as we want to have. They're just kind of represented with these fairly simple rectangular shapes. But the information is available if we go to the drafting views. And in your browser, if you expand drafting views, you'll see that there are a lot of them. The one that we're going to access here is going to be this one called the 6-inch, 1-inch over 1/4 inch horizontal mullions 3. And as I mentioned, this particular detail, the one on the right, shows us some information that we can use as a basis for generating extrusions for the back pan on the spandrel panel. So we'll click on that, and all we have to do here is just do a simple Control-C to copy it to the clipboard. And then I'm going to go back to my elevation view in my other file. Remember, that was a separate RVT file that we were looking at from Conair. Now that I'm back in my 3D detail RVT file, I can see the steel stud that I created earlier, and I'm just going to go to my Modify tab, and I'm going to click on Paste from Clipboard. I'll get a little prompt here about some duplicated graphics. I'll just click OK, that's not a problem. And these little blue dotted lines indicate that I've now got my Conair mullion detail, and I just have to click to place it. I'm going to do that fairly randomly and worry about the exact placement in a moment. I'll just click on the green check to finish, and there again is that's going to be the basis for my more complex mullion extrusion. Before I start doing that, I want to make sure that I've got this all properly placed, so I'm going to just initially move this mullion so that it is right at the edge of the slab. I'll then move it out 25 millimeters just so that we get a bit of a gap there for thermal expansion and fire stops. And now that I've got that in place laterally, I want to put it in the right spot vertically, and I'll just maybe move the bottom of the mullion right up to that 300 millimeter line, and that should do it. Okay. So now that it's in the right spot, I would just go through the same set of steps to create an extrusion for the mullion, and then eventually for the back pan, and then for these panes of glass. It's a fairly tedious process, so I'm not going to walk through every portion of that, but just to kind of kick it off and show you how it begins, I'm going to go once again back to my Architecture tab. I'll click on my component tool and access Model in Place. I'll choose once again Generic and click OK. Accept the name, and then I'm back to using the Extrusion tool, specifying my reference plane, which once again will be front detail, clicking OK, and then now starting this long process of using the Pick Lines tool to select the essential lines that I need for the generation of the mullion. So I'll begin that process, and then I'll just kind of pause and come back to when it's finished. So we'll go around this shape here and just select all of our crucial information. It can be a little tricky deciphering what's necessary, but it's going to look something like this to begin. Just pay attention to the lines. You can see that this is actually kind of 1/2 of the mullion. As is always, you're going to have to make sure that you've got a nice closed shape to generate the extrusion from. It's going to require that you have no gaps or overlaps. So I will just complete this initial extrusion, and then, like I said, I'll pause things and show you the finished work with everything else. And you have to just pay real close attention to how far these go. You can see that this is going to be quite a large object. Maybe I'll just cut this off just so we can kind of see what the finished product looks like, and then I'll come back and show you a completed object. So this is a little artificial, but I'm just going to cut this short right here and delete these lines. So I'm pretty confident I've got a closed shape here now without any gaps or overlaps. But when you get into something more complex like this, I find it's always a good idea when you're about to click the green check to zoom out so you can see the full sketch. And if there are any errors, as there will be, let me click on the green check and show you, you can see that it highlights the errors with an orange highlight. So now I'll know where I need to go to make my little edit and fix this. Now I'm pretty confident I've got a closed shape, so I can just click on the green check. taking note, of course, of my extrusion end and extrusion start numbers and my material. So maybe I'll set this to be something a little larger, like 1500, and then I'll click on the green check. And once again, I don't need any additional sort of geometry here, so I'll click on the green check, and I'll go to a 3D view. And there's that first part of the mullion. So lots of really nice detail in there, as you can see. I'm going to just kind of continue the process by going back to my south elevation view and adding more to this. Okay, after all that very tedious, arthritis-inducing work, we're left with something that looks like this. So you can see that the way that I built this, I've actually built it as one complete object. You wouldn't necessarily have to do that. You could create your model in place components in different sessions so they didn't all select together. But you are still able, when you do that, to have different extrusions. So if I click Edit in Place, you'll see that I can select each of these individually, which means that I can specify different materials here and different extrusion ends and starts. So you do still have some customization available to you if you create this all in the same session. As you can see, that particular detail that I downloaded from Conair allowed me to have a spandrel panel on the back. So that's that item there, and then I kind of added some insulation, which isn't really indicated too clearly, but that just kind of introduces the idea here that you're going to have to do a little bit of customization and tweak things as you go. So that gives me, as you can see from the 3D view, my concrete slab, which of course was just a regular, just sort of common generation method there for generating the floor in Revit, and then I added the steel stud tracks, and then that long process of using the details that I had from the website to generate the extrusion profile for the mullion and all of its bits, its gaskets and seals, and then of course these glass panes, and then the spandrel panel pane below. And that's all done. I'm not quite finished yet. There might be some elements here that you have to add or can add without necessarily having any 2D details. So if, for example, I wanted to add a little bit of millwork on top of this, just to kind of cap the steel stud wall and fill in the gap between the mullion and that wall, I could just kind of make this up without any 2D information. So I'll give that a shot here and just go back to Architecture, Component, Model in Place, and I'll make this again generic, accept the name, and then create an extrusion that will once again be based on front detail. And as I said, now I'm just going to create maybe something that is a 1/2 inch, 12.7 millimeter just millwork piece. So I will just take that line and copy it up, 12.7, and just use the regular line tool here, and maybe have this come right to the back side of the mullion, and then I'll have something out here that maybe has a bit of a fillet to it. So I will just use my trim extend to corner tool to wrap this up. Same thing here, and then like I said, maybe on this particular edge I'll just round that out a little bit, maybe give it a 9 millimeter radius, and assign a material. Look for something maybe with a wood finish from the library. Click OK. I'll stick with the same extrusion length for that. And there we go. So now I've got most of the components here for my spandrel panel wall. The last thing I'll point out here is just that you can, of course, like I did with the floor, incorporate some just regular Revit elements. If I want to indicate some drywall, perhaps I could just do that as a regular wall type. So in my level 1 floor plan view, I could just go to the Architecture tab, click on the Wall tool, start with something generic like a 200, and then click Edit Type and make a duplicate, and I'll just call this my 15.9 millimeter type X gypsum wallboard. And then of course I will make the changes here. 15.9, specify a material. Let's see if I've got something close to gypsum wallboard. Click OK, and then I'm going to specify that this is just 300 millimeters tall, so it fits underneath my sill plate, And I'll just place it just roughly to start, and then get a little bit more particular about the placement maybe when I go into my elevation view. And I can see here that I should actually increase the length of my millwork, which I can do fairly easily here by just editing in place, editing the extrusion, and then just stretching this fillet out a little bit. Something that might look like that. And then the last thing I want to do here maybe is just specify a different length for this gypsum wallboard, so maybe it matches up with the rest of the extrusion. And there we go. Okay, maybe one last thing I will mention, I guess, is that I would want to, of course, for a spandrel panel, just take the elements that I have here, so the mullion and then the panes and the gaskets, and then just flip them around so that they cap down at the bottom. So I'll go to my self-elevation view one more time. This is maybe one of the benefits, I guess, of having made these all sort of built together, is I can just take this element and then just use my mirror draw axis, and it's going a little deeper than I want it to, but I could edit that and tweak that a little bit later on. Now you can see that even though I have a seam there, it does look like a bit more of a sort of typical spandrel panel. And there we go. As I said before, when this is all done, I have the ability here to set this up like I would a normal view. I can use my view cube to maybe get to something like a recorded sort of preset view. And then as you can see here that I've got my graphic display options turned up so that I have anti-aliased lines. I've got both of my shadows, cast and ambient, turned on. And then I can play around with the light to get the amount of shadow and light and highlight that I want. And that now becomes a view that I can, just like we saw in this starter image, just drag onto a sheet, and I can make that part of my working drawing set.